Okay, for the Bell assignment, I'm going to give you one example because for some reason we freak out whenever I put these on the board and we act like we don't know what to do. So for the first one here, we'll call these A, B, and C. Okay, I want you to complete the table and graph the function. So I'm going to show you how you complete the table, one example really quick. For A, we have y equals 1/3. And then instead of x, we're going to plug in the x values here. So my first x value is -6, so I plug in -6 plus 2. 1/3 times -6 is -2 plus 2, okay, which leaves me with y equals 0. So I plug in 0 for y. Whenever I plot this, my coordinate will be -6, 0. Okay? So, go ahead and pause the video and complete those at your desk. Put them on the board, go over them together. What we're talking about today is lesson 62, graphing solutions to inequalities on a number line. Tom was thinking of a number between 1 and 10. Of what possible numbers could he be thinking? We might assume that Tom is thinking of a counting number greater than 1 and less than 10, such as 3, 6, or 7. However, Tom could be thinking of 2.5 or pi or radical 20. Any of those things also fall between 1 and 10. 2.5 obviously does. Pi is equal to 3.14. And if you punch in radical 20 into your calculator, which is the same as the square root of 20, that will get you 4.47, which is also between 1 and 10. Okay? We can write an inequality to indicate the range of possible numbers. Letting x represent a possible number, we write, okay, and I have that 1 is less than x, which is less than 10. The reason that we say that is because the number that we're talking about has to be less than, or excuse me, has to be greater than this 1, okay, and less than the 10. So it has to fall somewhere between those two. We read this inequality in both directions from x. We can say x is greater than 1 and less than 10. Notice that both the description and the inequality exclude 1 and 10. Exclude means it does not get included, and the way that we know it doesn't get included is because there's no equal to. We can use the number line to graph the possible numbers of which Tom could be thinking. So on the number line, I've listed the numbers between 1 and 10, the integers, or not 1 and 10, -10 and 10, and then we have open circles here at 1 and 10. Those open circles mean that we do not include that number. We don't include that number because there's no equal to with the inequality. So at the top here is the exact same graph that I had on the last slide. The shaded portion of the number line represents the range of choices for Tom's numbers, or for Tom's number. The word between suggests that Tom's number is greater than 1 and less than 10. So the small circle at 1 and 10 indicate that those numbers are excluded from the choices. To show that those numbers are included, we would make a shaded dot. So our symbols here, we have our first one, which is less than or equal to, our second one, which is less than, third one is greater than or equal to, and our fourth one is greater than. Which tells you how to read each of those. The example that we have, x is less than or equal to 3. First of all, we have a shaded circle because it has the equal to symbol. Okay? Then we know which way to shade because as long as my variable is on the left-hand side, I can turn my inequality symbol into an arrow and it tells me which direction to shade. So it says to shade it to the left, so it's shaded to the left. On the next one, I don't have an equal sign with my symbol, so it is an open circle. I make my symbol into an arrow, it's pointing to the left, so I shade to the left. Okay, and the point I was talking about there was 5. The next one says x is greater than or equal to negative 2. Greater than or equal to, it has the equal to with it, so we put a shaded point, and we're talking about negative 2. So my shaded point goes at negative 2. My variable's on the left-hand side, so I can turn my symbol into an arrow. The arrow points to the right, so I shade to the right. The last one says that x is greater than 0. I don't have an equal to, so I know it has to be an open circle, and the point I'm talking about is 0. So I put an open circle around 0. My variable's on the left, so I can turn my symbol into an arrow. The arrow points to the right, so I shade to the right. Christina is thinking of a number. If she doubles the number, the product is greater than, and this says F, but it's supposed to be a 4. I meant to, you scared me. It is on my thing. Sorry, Mr. Dotson just walked in. Give me a second. Okay, sorry for screaming in your ear, but it's 6 o'clock at night. I'm still working, and Mr. Dotson brought me some supper, so he's a keeper. Alright, back to what we were talking about. Christina's thinking of a number. She doubles the number. The product is greater than 4. Write an inequality for this description. Graph on a number line all the possible choices for Christina's number. So it says that she doubles the number that she's thinking of, the number that we don't know. So the number we don't know is x. If she's doubling the number, she's taking 2 times x. And then it says that it's greater than 4. So this is doubling the number, and its product is greater than 4. It says to write an inequality. We've done that. Graph on a number line all the possible choices for Christina's number. Now, since we don't really know how to solve inequalities yet, I'm going to give you a little hint here. Whenever you have an inequality and you're trying to solve for the variable, you treat that inequality symbol the exact same way that you would an equal sign, unless there are negatives involved, and right now there aren't, and there won't be for a while. So if I had 2x equals 4, to get x by itself, instead of multiplying, I would divide, because we have to do the opposite. So I divide by 2. What I do to one side, I must do to the other. Those will cancel out, so I get that x, my sign stays the same, so it's greater than. 4 divided by 2 is 2. So this is what I want to graph on my number line. Whenever you do this, make sure that you just include the number that you're talking about, okay? So it doesn't have to be one big huge number line. Show me 3 numbers, the number you're talking about, and a number on each side of it. So the number I'm talking about is 2. Because my sign is just greater than, my sign will be open. Okay? My variable is on the left-hand side, so I can turn my inequality sign into an arrow. The arrow points to the right, so I shade to the right. So this is what the graph looks like. Okay? It says solve and graph the solution to this inequality. So I have 3x plus 1 is less than or equal to 7. Once again, we treat the inequality symbol the exact same way that we would an equal sign. So, whenever I'm solving for a variable, I want to move everything away from that variable. So, the variable is on the left-hand side, my x, and I have 3x plus 1. That's what's on the left-hand side. The farthest thing away from my x is 1. Right now it's being added, so I want to do the opposite. I'm going to subtract 1, and what I do to one side, I must do to the other. Those will cancel. I'm left with 3x on the left side. Bring my symbol, my sign, straight down, and I have 7 minus 1 is 6. Now I have one step left. 3x is less than or equal to 6. To get x by itself, I have to do the opposite, so I have to divide by 3 on both sides. So I'm left with x is less than or equal to 6 divided by 3 is 2. Now it tells me to graph it. So I show my number line. 3 simple points. The point I'm talking about is 2 and one side or one number on each side of it. So this time my sign has the equal symbol. Okay, it's less than or equal. So because it has the equal, my circle is going to be closed in. And if I turn my sign into an arrow, I point to the left. So I shade to the left. Okay, final answer. It says when applying inequalities to situations in the real world, we might be limited to positive numbers or whole numbers, as we see in the following example. Vincent goes to the store with $20 to buy a notebook for $4. He notices that packages of notebook paper are on sale for $2. Write and solve an inequality to show the number of packages of notebook paper he could buy if he also buys the notebook, ignoring tax. Then graph your solution. So, he goes to the store with $20. So I'm going to start by writing $20. All he has in his pocket is $20. That means he cannot spend more than what he has. So the max he can spend is $20. He can spend all of it, but he cannot spend over that. So he must spend less than $20. Whoops, that's going to be backwards. $20 has to be greater than or equal to what he's spending. Okay, whatever's on this side over here has to be less than the 20. So now I also know that he wants to buy a notebook and it's $4 for just the notebook. So I'm going to put my 4. Plus, he wants to buy packages of notebook paper and they're on sale for $2 each. So I'm going to show $2 each by writing 2x. So this tells me that if he spends, or if he buys a notebook plus 2x, that has to be less than or equal to $20. And right now my x is on the right hand side, and I generally like to have it on the right hand side. So I'm going to rewrite everything. 2x plus 4. My sign now has to flip. Where it was pointing before, it must still be pointing. It was pointing at the 2x plus 4, so it still points at the 2x plus 4, and then I bring down my 20. Okay, all I've done is rewrite it and flip my sign. So now I want to get x by itself because it asks me to solve, right? Does it write and solve? Yes, it asks me to solve the equation. So to get x by itself, x is on the left-hand side. The farthest thing away is 4. The 4 is being added. The opposite is to subtract. So I subtract 4 from each side. Cancels. I'm left with 2x is less than or equal to 16. To get x by itself, it's being multiplied by 2, so the opposite would be to divide by 2. What I do to one side, I must do to the other. Cancels, leaving me with x is less than or equal to 8. Okay? That means that he can buy 8 or less packages of notebook paper. Okay, so I'm going to graph it. So I'm going to put my 8 over here. 7, 6. Okay, and whenever I graph this, I know that I can get 8, but it has to be 8 or less. Can I buy half a package of notebook paper? The answer to that is no. So because I can't buy half a package, I have to put points on the integers because I can't buy 3.5 packages of notebook paper. So I couldn't have a point that fell between 3 and 4. It has to be exactly at those integers, those whole numbers. Now, I stopped at 0. My next question is, could he buy -1 packages of notebook paper? No, they're not going to pay him for not buying a package of notebook paper. So he either buys 0 or somewhere between 0 and 8. Okay, as much as 8 packages, but he doesn't have to buy any if he doesn't want to. So there's our final solution there. Now it says solve and graph this solution. So again, I'm trying to get x by itself. Right now, x is having negative or having 2 subtracted from it. The opposite of subtracting 2 is adding 2. What I do to one side, I must do to the other. These will cancel. Bring down my x, bring down my sign. 3 plus 2 is 5. Now I've told you multiple times that we generally like to have our variable on the left-hand side. So what we're going to do is we're going to flip it just like we did before. I'm going to write my x over here, and wherever my sign was pointing, I have to make sure it's still pointing there, so I flip my sign also. So I will have greater than or equal to instead of less than or equal to, and I'll put my 5 on the other side. Now whenever I graph it, I put my 5, show 1 on each side of it. My point is at 5, okay? Because of the equal to, it will be filled in. If I turn my sign into an arrow, it points to the right. Final answer. Homework for today is lesson 62, A through F, and 4 through 24 even. It is due tomorrow when you walk into the room. Please make sure that you have it done.